Good morning, ladies and gentlemen. Today we're going to look at using the unit circle and trigonometric identities, specifically this one, to solve trigonometric equations. So it's about finding solutions. Rather than finding x, we're finding theta, but it's the same principle. We're going to find possible solutions, and we're going to use certain tools available to us. Primarily, that identity and the unit circle. So, without using a calculator, find sine theta if cos theta is 2/3. Now, note, we don't have to find what theta is exactly, we have to find cos theta. So if we're doing this, a really good place to start anytime you see sine and cos linked is to recognize they're actually linked in this formula as well. So start with the formula. Sine squared theta plus cos squared theta equals 1. Now, if you know that cos theta is 2/3, you can make that substitution. So, sine squared theta is plus 2/3 squared equals 1. So what's happening is we're taking cos squared theta and recognizing that because cos theta is 2/3, cos squared theta is 2/3 squared. Right, then we go about solving. So, sine squared theta plus 4/9 equals 1. Remembering the squared hits both the top and the bottom. Then take 4/9 from both sides. Sine squared theta equals 1 take 4/9 is 5/9. Then we square root both sides. Sine theta equals plus or minus the square root of 5 over what would be the square root of 9, but just 3. Typically, we write the over symbol there. Plus or minus root 5/3. Alright, so here we start with the identity and solve for theta. Then it's worth drawing the unit circle, draw the solutions, and checking which solution we're after. Here we found what sine theta is. So we want to find sine theta, but we've got two answers. So let's think about those answers. We're told that sine theta is either plus root 5/3 up here, which is up there. So each of those could be root 5/3 high. Or our second solutions are minus root 5/3. Minus root 5/3. But we are told that our solution is between 0 and pi/2. 0 and pi/2 is this portion. So if theta is in that portion, we can say that sine of theta is equal to positive root 5/3. It must be the positives. If our domain restriction was somewhere else, it might be that this double answer was negative. If there's no domain restriction, then we can consider giving both answers. So, sine theta equals root 5/3. Now, we can't solve any further than that without a calculator, so we leave it there. We're only asked to find sine theta. You can go through a similar process solving for cos theta by starting again with this identity. And that will be the starting point of our lesson. Alright, heading down. What about this one? It's the same style question, but this time with tan. Find the exact values for sine and cos, sine theta and cos theta, given that tan theta equals 2/3. Alright, so tan theta equals 2/3. One thing to remember is that tan theta is equal to sine theta on cos theta. So that will be our first substitution we're making. We want to find sine and cos, so we need to introduce them into the equation somewhere, which is going to be here. So rather than tan theta, I'm going to say that is sine theta over cos theta equals 2/3. Alright, from there, I'm going to multiply both sides by cos theta. Sine theta is equal to 2/3 cos theta. Alright, we haven't found what either of them are exactly, we just haven't found them in terms of each other. So we can do slightly better than this. We can then use this substitution of, I'll write it over here actually, sine squared theta plus cos squared theta is equal to 1. Alright, if I know that sine theta is equal to that, I can find sine squared theta in terms of cos. So really, it's going to be 2 on 3 cos theta all squared plus cos squared theta equals 1. Sorry, 1 second. Alright, here we need to simplify. So, simplify, and we're going to simplify and solve for cos theta. This squared goes in to hit both those things. That 2 on 3 squared becomes 4 on 9. This becomes cos squared theta plus cos squared theta equals 1. Now, really, that is 1 lot of cos squared theta and 4/9 lot of cos squared theta. 1 plus 4/9, well, 1 is 9/9 plus 4/9 is 13/9 of cos squared theta equals 1. Alright, now we divide both sides by 13 on 9. 1 divided by 13 on 9, you keep change flip, is 9 on 13. So cos squared theta is 9 on 13. Cos theta is plus or minus 3 over root 13. The 3 coming from the root 9. Alright, we have been given that theta is between 0 and pi on 2. So we can be guessing here that it is going to be positive, because cos is only positive in that quadrant. So therefore, cos theta is equal to 3 on root 13. Now we need to know what sine theta is as well, so we can get that from here. Sine theta is equal to 2/3 of cos theta. And cos theta is 3 on root 13. Therefore, sine theta is equal to, the 3's cancel, 2 on root 13. Sine is 2 on root 13. Cos theta is 3 on root 13. And that's what we're asked to solve. Note, if you do sine divided by cos, sine divided by cos, those root 13's can cancel, and you're going to get 2 on 3, which is a pretty neat result, because that's what you're expecting if sine on cos is 2 on 3. Alright. Next step. These are 3 different rules that are very much like the rules that we've been using so far in this highlighted one. They're rules that are going to a cheat sheet, and you'll need to know vaguely where they came from, but also how to use them. They look really scary because it looks like there's 6 rules. There's only 3, and they're not that scary, simply because I think they come from a very logical place. Take the unit circle. Also, if you're sitting at home and wanting to draw nice circles, 20-cent coin is the perfect size for it. Lots of math students I know keep a 20% coin in their pencil case so they can do this regularly. Alright, let's consider this first one. Actually, I can make a better circle, can't I? So I have a tool for it. Look at that. Oh, it's glorious. Alright, unit circle. Let's explore this one. given a value of theta here, this length here, by definition, is sine theta. Alright, let's consider this other side. What does sine of pi take theta look like? Well, pi take theta looks like this. Pi take theta is I go around pi and I take theta away. So this angle is pi take theta, with this one in here being the little theta. And turns out they're the same height. And they're the same height, and what that means is that sine of pi take theta is exactly the same as sine theta. It is the same height. So, in degrees terms, it's perhaps easier to understand with this, if you have sine of 10, that will be equal to sine of 170. Because 180 take 10 is 170. They're exactly the same. Similarly, sine 30 is equal to sine of 150. Because 180 take 30, they're the same. Alright, how does this rule work with cos? Well, you might notice that this is the same related setup. If this here is cos theta over, that's that gap there, cos theta. Now, this gap will be exactly the same, but it's going to be negative. So therefore we say that cos pi take theta is the same as cos theta, but one of them has to be negative. This rule I think will actually make more sense if this negative lived on this side here. So if it makes a plus and then a minus theta, I've just rewritten maths for you. It doesn't matter where that negative lives. The rule is the same either way around. It's just dividing both sides by -1. You get back there. All right. Let's consider the third rule there. Same sort of logic. I'm not going to get it all without rubbing. Oh no, I ruined my circle. Same sort of logic. Let's consider this. Cos theta. Cos theta looks like this. If that's theta, this length here is cos theta. Alright, what does 2 pi take theta look like? Well, 2 pi is all the way around. Take theta is this. 2 pi take theta is going to give me the same length exactly, which is why theta equals 2 pi take theta exactly. The rules look really scary, but once you know how to use the circle, you recognize that these are essentially common sense. Alright, so find two angles theta on the unit circle between 0 and 2 pi such that. Alright, so we have this cos theta equals -1/4. Now, the first angle you're going to get, unless it's a special case, as in unless it's a 30, 45, 60, if it's not one of those fancy ones, then you are going to use your calculator. So to use your calculator, you just want to find theta equals cos -1 -1/4. Theta equals cos -1, oh no, negative 0.25, enter, 1.823. Alright, 1.823. Alright, we want to find two angles. So then we consider the unit circle. Your calculator will give you one answer. You need to use your unit circle to get a second one. Alright, so cos of -1/4 is this here. You can imagine this gap here being -1/4. That angle is 1.823 radians. Alright, that's 1.823 radians. We need to find our second angle that gives us the same -1/4. So we need to find another -1/4. Well, the other one comes from down here. And we can do another angle here. If we want to find this second one, we do 2 pi, which is all the way around, minus 1.823. And that will give us the same -1/4. So then we go to our calculators and write 2 pi, oh, my recorder's getting in the way, 5 pi minus 1.823 equals 4.46. So if that's 4.46, what that means is that from here around to there is an angle of 4.46. We would normally see it drawn in here. 4.46 radians. So your first answer comes from the calculator. The second comes from either the circle or a rule. That will give you the second one. Similarly, we could have maybe used this rule to get the negative, but this is the one we're after. All right. So, what about sine theta? Sine theta equals 0. Well, sine theta equals 0 happens in two places. You might not even need a calculator to get you this. Sine is how far up it is. If it's 0 up, we're on this point here, or we're on this point here. Sine theta equals 0, very simply, is 0 and pi. Now, here's a technical bit. If I was being really mean, and the examiners and me are really mean, see how this says between 0 and 2 pi? We have two solutions. We have 0, we have 2 pi, and technically, and this is one everyone always forgets, there is a third solution. 2 pi, which is mean. So there should be 3 solutions here in that domain. And be careful of that. That is a common methods trap where they make sure people understand the difference between a strictly less than and a less than or equal to in the domain and what that means in terms of the number of answers. So I guess be warned. Alright, tan of 3.1. Once again, starting with the unit circle. Now, tan of negative 3.1 is hard to visualize. Best thing to do is solve it using our calculator. So theta equals inverse tan negative 3.1. Grab our calculator. Inverse tan negative 3.1 and minus 1.25875. Now, minus 1.25875 is going to be about here. Minus 1.25. All right, and down here, tan is negative. We also need to find the opposite side here, where tan is negative as well, where this angle is 1.25. Now note, there's no rules here with tan on it. Oops, didn't mean to drag that up there. There's no rules with tan on it. So instead we have to rely on a little bit of logic. Our little bit of logic is, if we want this answer here, and the calculator's given us this one, weirdly enough, this one doesn't even fit within the original domain. Minus 1.25, it doesn't fit between 0 and 2 pi. It's just given us this little reference angle here. So, how do we actually find the angles we're after? Well, here is pi on 2. So to get all the way around to this one, we do 1.25 plus pi on 2. So then we can just go plus 1.25 plus pi divided by 2, 282. So our first answer is theta equals 282, which gets us to here. Alright, looking in red for the second answer. The second answer is this one here. And a negative isn't acceptable because we need to be between 0 and 2 pi. And 2 pi is 6.3. We need to be between 0 and 6.3-ish. To get this, we start here and we want to go around like that. Best way to find that red is to go all the way to 2 pi, then minus 1.25 off again, and get us back to this angle. So we go 2 pi minus 1.25, 503. I guess that's the answer. Alright, I apologize, this video is longer than normal, but being able to use the unit circle to get out a second answer is an incredibly important skill that we will practice again and again and again. Alright, hope you have a lovely evening. Goodbye.